This conference will now be recorded.
All right, this is the extra examples from section 2.6. We have for Math 211, this is example 2. This is written in equation format, and this is implicit derivatives as well. A lot of students have a harder time recognizing this because they don't see the y, but remember f of x is y. So I'm going to do this with the f of x intact because I feel like you need to practice it with multiple notations, but you could change the f of x's to y and do it that way as well. So since we're taking d dx of this, we're going to write that in front of each term of this equation. Notice we have a product rule right here for the second term because we have x squared times f of x that is being cubed, and then d dx of 10. So because this is y, that means that we need to do implicit derivative here. So remember, dy dx is what we normally would have written, but for this scenario, we can write the equivalent form of that, which is f prime of x. Plus, this one we're going to have to do a product rule on. So first times derivative of the second, so that's going to be a power rule, so 3f of x squared. And because the f of x is an inside function, we need to take the derivative of it for our chain, and it is y again, so we're going to have f prime of x for that. So just this portion right here that I'm underlining, that's the derivative of this guy. Plus, then we would get the second function first this time, times the derivative of the first, which is x squared, so we can just do 2x. There's no implicit dy dx essentially in that part. And then that whole thing is equal to 0 because derivative of 0 with respect to any, or 10 with respect to anything is 0. So I'm just going to try to clean this up a little bit. This is f prime of x plus 3x squared f of x squared times f prime of x plus 2x f of x cubed equals 0. They told us that f of 1 is 2 and f prime of 1 is what I'm solving for. So if I wanted to, I would probably move this over since it does not have an f prime. That would make that negative 2x f of x cubed. And then we can pull the f prime out of this so that we can solve for it. That would leave me with a 1 for that first term, and then the remainder pieces here. So f of x squared equals this, f of x cubed. And then I would divide that over so that I have my f prime by itself. So that would be negative 2x f of x cubed, and that's over 1 plus 3x squared f of x squared. Okay, so now we're going to plug in 1 for all of our x's. So f prime of 1 equals negative 2 times 1 times an f of 1 cubed over 1 plus 3 times 1 squared times f of 1 squared. Okay, f of 1 can be replaced with 2, so this is really negative 2 times 1, which is negative 2, times a 2 cubed over 1 plus 3 times 1 squared is still going to be 3, but this is going to be f of 1 again, which is 2, and it is being squared. So if we work that out, we get, this will be negative 16 on top. This is 4 times 3, which is 12, plus 1 is 13. So the overall answer is negative 16 over 13. And then the other one we didn't get to in class, kind of a challenge problem. Here is a function that's written implicitly in terms of both x and y, and we want to find the second derivative and evaluate it at 1. Now, because they didn't actually say just find y double prime of x, I'm not so concerned with actually getting that final equation format for that. I just want to be able to evaluate it. So I'm going to show you that first of all, to be able to evaluate this, notice that when we took these implicit derivatives, we still get usually x's and y's in our final answer. So we have to know the ordered pair for the original function or equation here in this case. So we're going to be taking 1 and plugging it in for all the x's, and we're going to try to solve for y to figure out what that ordered pair would be. So if I plug in when x equals 1, we would say that this is 1 squared plus 1 times y plus y cubed equals 1. I can solve that by subtracting over that 1, so I just get y plus y cubed equals 0. Factor out a y, that would leave me with 1 plus y squared equals 0. And if you set these both equal to 0, this one is imaginary solutions, so that's not going to work out for here. So it's going to have to be this. So the ordered pair on the function is that when f of 1 is plugged in, we get an answer of 0. Now, let's go ahead and take that first derivative implicitly. So I'm going to try to make marks so that my first derivative, anytime I have to chain that y prime on, I'm going to do it in a different color. So this would be d dx of x squared plus d dx of xy plus d dx of y cubed equals d dx, derivative with respect to x, or that's what that stands for, of 1. So for the first one, we just get a 2x since it is the correct variable. We're going to get a product rule here. This is a first function and a second function essentially. So first times derivative of the second. Well, the derivative of y would be y prime. That's like the dy dx. And then go back to black. Then we write plus second times derivative of the first, which is x, which would just be a 1. So this right here, this little piece, this binomial, that is that product rule. Plus, this is y, so we're going to get a 3y squared, but we have to tack on that chain of a y prime. And then equal to 0. So let's try to isolate y prime. So we're going to solve for it in a second. So y prime, if we get it on one side by itself, the two terms that kind of go with that guy, so I'm going to leave them over here on the left, is an x and a 3y squared. So notice I'm already factoring those out of those terms right there. I'm going to subtract the other two terms to the other side of the equation. So I get a negative 2x and a minus y. Those are the ones that did not have a y prime attached to them. And so my answer is going to be a negative 2x minus y over an x plus 3y squared. And that's going to equal y prime. And I care about this one because I need the value of y prime at 1. So y prime of 1 is going to equal, because we have to plug in the ordered pair 1, 0, this is going to be negative 2 of 1 minus 0 over 1 plus 3 times 0 squared. So that's negative 2 on top, and that's just going to be a 1 on bottom. So now I know that y prime of 1 is a negative 2. And that'll help me on that second and final derivative that I'm about to take. So I'm going to write that a little clearer. So here's what I know so far. When you encounter f of 1, or when you plug in x equals 1, you get a y of 0. And in the first derivative, y prime of 1 equals negative 2. So this next time, I'm going to go back to this line right here. And instead of trying to take an implicit derivative of this big fraction, I'm just going to take an implicit derivative of this line. And we'll just remember that if we take a derivative of something that's already a derivative, it becomes the next derivative in the series. So it'll become like a y double prime. So again, let's rewrite this as all d dx's taking with respect to x. So d dx of 2x plus d dx of xy prime, which I'm not so worried about the color right now, plus d dx of y plus d dx of 3y squared times y prime, and equal to d dx of 0. Okay, so let's take these individual pieces. And anytime I encounter the y prime, I'll put it in red if that's my answer for that part. And if I have to go with a derivative of y prime, I'm going to put it in blue this time. So derivative of 2x is going to be just 2. Now this part is a product rule, so I'm going to have to be careful here. So this would be first times derivative of the second. Now that is a y prime, so when we take the derivative of it, it becomes a y double prime. And then plus, because I'm still not done with my product rule, and then we would write second, which is the y prime, times the derivative of the first, which is a 1, plus derivative of just y would be y prime. Now for this very last one, we're going to get another chain rule here because these are different creatures. This is a y in the just variable term, and this stands for, remember, the derivative of that. So when we go to write our product rule here, it's going to be first times derivative of the second, so that turns that into a y double prime, plus second, which is y prime, which I need to write in red, times the derivative of the first, which would be a 6y, but because it's a y, we have to tack on another y prime. So this guy ends up having a y prime squared in this term. And then that equals the derivative of 0, which is 0. So let me just clean up what I can a little bit before we do any plugging in. So this is 2. I'm going to put all my y primes that are singular together, so I have 2 of those. So that would be 2 y primes. Oh, I wanted those in red. Because I'm just adding those 2 like terms together. Then I had that other term that had y primes in it. That was plus 6y, and then it's a y prime squared. And then all of my other terms had the blue in them. So plus x y double prime and plus 3y squared times y double prime. Just color coding this so you can kind of follow along what we're about to do. Equals 0. Now, if I really wanted to know what this function was, like if I actually wanted to know what is the second derivative as a function and not just evaluating it, I would need to plug this equation for y prime into all of the red spots and kind of get common denominators for everything, and then move for these 3 terms, and then move it over, and then pull the y double prime out of this pair, and then divide over that x plus 3y squared. We don't need to do all of that for this specific problem because all we want to know is the evaluation of y double prime of 1. So essentially, we're going to imagine we can plug in everything we know so far about this problem. So 2 plus, and remember we know the following things. Y prime of 1 is going to be negative 2. So right now I'm actually going to write that before I plug it in because I'm evaluating this at 1. And remember our x is 1, our y is 0. So this is going to be 6 times 0, and then y prime of 1 squared plus 1, because remember our ordered pair is 1, 0, and we know that y prime of 1 is negative 2, which we're going to substitute that in a minute. 1 for x, so this is just going to be, I'm going to keep this guy blue since this is the one we're solving for. So y double prime plus 3 times 0 squared, y double prime again, equals 0. So because we're worried about when x equals 1, we get to use this ordered pair anytime we encounter just a regular old x or y. We will get to plug in negative 2 anytime we've got the y prime of 1. And I'm going to go ahead and write that these are both y double prime of 1 because that's what we're solving for. Now, we can clean up some of this because there's some zeros here. This whole term is going to get zeroed out because of that 0. So this is just 2 plus 2. I can replace the y prime with a -2. This is 0. I have my y double prime of 1. And this whole term right here also zeroes out because of that y value that was there. So this equals 0. So this is 2 minus 4 plus y double prime of 1 equals 0. That's -2 plus y double prime of 1 equals 0, or y double prime of 1 equals 2 if you add it over. So we were able to take that second derivative. It gets a little messy. It's better to not do it from this format though usually. Some people do, but if all you're going to do is an evaluation, I would just use the y primes and y double primes. It just looks a little bit neater, less fractions to deal with. But if someone actually asked you, remember again, for the function or the derivative of something and they want it as y double prime of x, yeah, you're going to have to clean everything up and plug everything in. But evaluations are always a little bit smoother. So that's the end of this video. And like I said, this one's kind of a good challenge problem. And I will be finishing up the 2.7 notes in class with the 2.8 notes on Tuesday. So I hope everyone has a good weekend.